Hello class, this is Mrs. Albritton of Albritton's math class, AMC. Now today we're going to be looking at exponential and radical rules. Let's start with multiplication. The multiplication rule, if we've got the variable x and y where neither of them can be zero, would look this way. So we've got x to the a power times x to the b power. Notice we've got same bases, they're both x as our base. Well, when that occurs, the rule states that you add the exponents. So it'll become x to the a plus b. An example of that is if we've got 2 to the third power times 2 to the fifth power, we add the exponents, it becomes 2 to the eighth power. And then we would solve 2 to the eighth power. A power to a power looks like this. We've got the base x to the a power, and that is raised to the power of b. The rule states that you multiply those. So it will be x to the a times b power. An example, if we've got 2 to the third power, and that's raised to the fifth power, a power to a power, it becomes 2 to the 3 times 5, which is 2 to the 15th power. The power of a product. Here's an example, 2x, so we've got the factor 2 times the factor x to the a power. This is where both of the factors of the product gets the exponent. This will become 2 to the a power times x to the a power. An example of that would be, let's say we've got, in fact, we could just keep 2x, keep the same product, and raise that to the third power. Well, in this case, we'd have 2 to the third power, which is 8, x to the third power, which is x to the third, or x cubed, because we don't know the value of x yet. A power of a fraction. Let's say we've got the fraction x over y to the a power. This is similar to the power of a product in that each of the values get the exponent. This will become x raised to the a power over y raised to the a power. An example of that, let's say we got 2/7. This fraction raised to the second power. Well, we'd have 2 to the second power, which is 4. 2 squared is 4. 7 to the second power would become 49. The quotient rule is similar to multiplication, except instead of multiplying, we have x to the a power divided by x to the b power. And the rule states that what we do for that is we subtract the exponents. So for example, if we've got 2 cubed divided by 2 to the fifth power, this becomes 2 to the 3 minus 5. In that case, that would be -2, because 3 minus 5 is -2. Of course, we would be able to do something with this negative exponent, and you're going to see that in just a moment down here. 0 power tells us that any base raised to the 0 power is always, always, always equal to 1. For example, 2 to the 0 power is equal to 1, okay? 5 to the 0 power is equal to 1. 5,000 to the 0 power is equal to 1. 1,000,000 to the 0 power will always be 1. So any base that's raised to the 0 power stays 1. Negative exponents, for example, x to the negative a is written as 1 over x to the positive a. An example of that, let's use this one. 2 to the negative 2 power is written as 1 over 2 to the positive 2, or 2 squared, which is 4. And the fractional exponent. Now, a fractional exponent says that we have a fraction as the power. Here's an example. X to the fraction a over b. Notice that the exponent is a fraction. We have to use a radical sign to write that, or rewrite that, I should say. and it would look like this. If you recall, when we did radical work in Algebra 1, this is the index. So when we rewrite this denominator becomes the index, and then the radicand is the base to the a power. So this is how you rewrite a fractional exponent. Now, we could also write it this way. We could put parentheses, same index, same radicand, and we can put the exponent on the outside. Sometimes you'll see it written that way. So just realize they are the same. An example of that, let's say we've got 3/4. Well, let's say we've got, let's try 2 to the 3/4 power. I'm gonna make that look like an exponent. So in this case, we would rewrite this as the index of 4. This base is our radicand to the 3rd power. Or I could write it this way. Parentheses, index of 4, radicand 2, and I could put the exponent on the outside. All right, so that's it for this video.